Hello viewers, in today's class we are going to solve yet another very important and conceptual problem from definite integrals, right? So here we are going to solve this definite integral uh, which is in which the integrand is a sum of two absolute value functions, right? So let us solve this definite integral which is from 1 to 4. Here we have mod of x minus 1 plus mod of x minus 2, right? So let us first call this integral as I. Now viewers, in such problems where we have the integrand is a sum of two or more absolute value functions, it is better to write the integrand as f of x, right? So here let us assume that our integrand is f of x, and this is the sum of two absolute value functions, that is mod of x minus 1 plus mod of x minus 2, right? And now this integral I, it takes the form 1 to 4, and here we have f of x dx, right? Okay, now in such problems what we do, we should always try to write this function f of x as a piecewise function, right? It means this function f of x must be split into sub functions or in two or more functions in different intervals, right? So let us see how to write this function f of x as a piecewise functions in different intervals. Now see, here we have this number line, and the lower limit is 1 and 4 is the upper limit, right? So this is the lower limit and this is the upper limit of integration, right? And now let us see the integrand. See, here we have mod of x minus 1, right? So let us solve the expression which is inside these two vertical lines. So we have mod of x minus 1, so let us solve x minus 1 is equal to 0. It means we have to solve the equation by equating the expression which is inside these two vertical lines equal to 0. And similarly here we have x minus 2 is equal to 0, right? So we have x is equal to 1 and here we have x is equal to 2, right? So these points will be utilized to break the limits, right? So now see, here we have x is equal to 1, which is already present over here as our lower limit of integration, right? So the other point is x is equal to 2, right? So here let us take x is equal to 2, right? Or in other words we can say that 2 lies between 1 and 4, and here I am once again repeating x is equal to 1 is also a point where we have to break the limit, but this point itself is our lower limit, right? So now we are left with only x is equal to 2. So once we have obtained these critical points, then we can arrange these points on a number line, and now from this number line it is quite evident that we have to split this integral I as a sum of two integrals, right? That is I1 and I2, and I1 is from 1 to 2 and I2 is from 2 to 4, right? So now we can write here x is equal to 1 to 2, and here we have f of x dx, and then we have 2 to 4 and f of x dx, right? So now our prime aim is to express this integrand f of x as a piecewise function in these two intervals, right? So the first interval is from 1 to 2, and the second one is from 2 to 4, right? So this interval can also be written as when x lies between 1 and 2, and here x lies between 2 and 4, right? So now we have to find the form of this function f of x in these two intervals. So now let us first take this interval, right? So when x lies between 1 and 2, then f of x is equal to, see here we have mod of x minus 1, right? So when x lies between 1 and 2, then obviously x minus 1 is a positive number. So here we have plus x minus 1, right? So here we are utilizing the definition of absolute value function, which says that mod of x is equal to positive x whenever x is greater than or equal to 0, and negative x whenever x is less than 0, right? So now mod of x minus 1 is equal to positive x minus 1 because x lies between 1 and 2, right? And when x lies between 1 and 2, then obviously mod of x minus 2 is negative x minus 2, right? Because here x minus 2 will take, or the sign of x minus 2 is negative, and when x lies between 1 and 2. We can also verify the sign of these two functions by taking a particular value in the given interval. Now see, here we are taking the interval from 1 to 2, and let us take one simple value between 1 and 2, right? Say 1.5, right? So when we take 1.5, that is x is equal to 1.5, then x minus 1 is equal to 1.5 minus 1, that is 0.5, which is a positive number. So here we have positive, right? And when we take x is equal to 1.5 here, that is x minus 2, then we have 1.5 minus 2, that is minus 0.5. So this is negative, right? So here we have negative, right? So this is how we decide the sign of these two mod functions in the given interval, right? So now we can simplify it. So we have x minus 1, here we have minus x plus 2, and this is x and x get cancelled, so 2 minus 1 is 1, right? Okay, now let us take the second interval, and here we have f of x is equal to, see, when x lies between 2 and 4, then obviously the sign of x minus 1 is positive, right? So we have plus x minus 1, and when x lies between 2 and 4, then the sign of x minus 2 is also positive, right? And here we have plus x minus 2, right? So again we can adopt the same method of deciding the signs or verifying the signs by taking a particular value between these two numbers. So here let us take say 3, because 3 lies between 2 and 4. So x minus 1, the sign of x minus 1 at x is equal to 3 is 3 minus 1, 2, which is positive, right? So that's why we have here the positive sign, and the sign of x minus 2 can be taken as by taking x is equal to 3, so we have 3 minus 2, that is plus 1, so we have positive sign. So here we have positive sign. So now if simplifying it, we have x minus 1, here we have plus x minus 2, and x plus x is 2x, and minus 1 minus 2 is minus 3, right? So now viewers, we can write our function f of x equal to 1. See here f of x is equal to 1 when x lies between 1 and 2, right? So when x belongs to the interval 1 comma 2, right? And f of x is equal to 2x minus 3 when x belongs to this interval, that is from 2 to 4, right? So this is how we have expressed our function f of x as a piecewise function, or we have split this function in two intervals, and the form of the function also gets changed in the two intervals. And we have already seen how to find the form of the function in the given intervals, right? So now viewers, let us come to this expression, that is I is equal to the sum of these two integrals. So now uh, I1 is from 1 to 2, and when we are integrating from 1 to 2, fx is equal to 1. So here we have 1 dx, and then we are integrating from 2 to 4, and here f of x is equal to 2x minus 3, right? So here we have the integrand 2x minus 3 dx, and now we have two simple integrals, right? So the value of this integral is x, limits are from 1 to 2, and here we have 2x square over 2 minus 3x, limits are from 2 to 4. So now we can further write it as here we can substitute the limits and we'll take the difference. So we have 2 minus 1, and here 2 and 2 get cancelled, so we have x square minus 3x, and the limits are from 2 to 4. 2 minus 1 is 1, and here we have 4 square minus 12 minus 2 square minus 6, right? So we have 1 plus this is 16 minus 12, that is 4, and here we have 4 minus 6, so we have 4 plus 1 5 minus 2, so we have 5 plus 2, that is 7, right? Okay, so viewers, the value of this integral is equal to 7, right? So this is how we solve this important problem.